All right, so we've got this equation here, y equals minus 16x squared plus 266x plus 102 equal. Okay, so they tell us that y is in feet and x is in seconds, and so we could say y equals feet and x equals seconds there. And the question is, a rocket is launched from a tower. The height of the rocket, y in feet, and x in seconds is given in this equation here. And using the equation, find the time that the rocket will hit the ground to the nearest hundredth of a second. So backing up here, we've got a quadratic equation given because it's x squared. And one thing we know is when we graph all quadratic equations, we always end up with a parabola that goes like that or a parabola that goes like that. And so if we're graphing this all on a chart where the y-axis is here and the x-axis is here, the y-axis is the height of the rocket in feet and the x-axis is in time. And interesting things always happen when either x or y is equal to 0. So when you set y, the vertical one, to 0, you are now on the x-axis here. So y is 0 right in the middle. So it goes 0, 1, 2, that sort of thing, minus 1. And so conversely, when you set x equal to 0, which is right here, you're on this y-axis. So interesting things always happen there. So just an example, if we find out what happens when x is equal to 0, so if we set x to 0, minus 16 times 0 is 0, plus 266 times 0 is 0, and we basically just end up with this 102. So when x is equal to 0, y is equal to 102. So that means that when we're at time 0 seconds, our height, y in feet, is equal to 102. So that's something interesting that happens when we set one of the variables to 0, but what we're actually looking for is when y is equal to 0. And why do we want y equal to 0? Well, y is the height in feet, and we're looking for where the rocket hits the ground. So it's important to understand that the ground is at 0 feet above the ground. So the ground is where we call our 0 point. So we're basically just trying to solve this quadratic equation, which is something that I think you do a lot before you use it for real equations like this. So there's 3 ways to solve a quadratic equation. You can use the quadratic formula, you can use like factoring, and you can use completing the square. But in this case, this is a pretty big, complicated one. So I think the answer is you just use the quadratic formula. And the quadratic formula, I had forgotten the quadratic formula after all these years. The quadratic formula is, let me pull it up here. X equals minus b plus and minus the square root of b squared minus 4ac all over 2a. And when you solve this equation, since it's plus and minus, you end up with 2 answers. You end up with an answer of minus, I believe, 3/8 and an answer of 17. The important part is to back up when you have that answer and say which of those 2 answers make sense. So we're looking for the height we're looking for the time in seconds after the launch when it hits the ground. So just the fact that they say after the launch, this x value has to be greater than 0 to be after the launch. So 1 second, 2 seconds, 3 seconds is after the launch. If we're at minus 3/8 down here for an answer, that's before the launch. And that's because we've got these parabolas that form. And so if we're looking at our axis, we basically see something like this. And so we talked about at time 0, we're at 102. And so it turns out we are at the ground at -3/8 of a second. And we're also hit this ground, this y-axis of 0 at 17 seconds here. And that's our answer because that number is after the launch. And basically all we've done, once again, is just solve this quadratic formula, quadratic equation with the quadratic formula. And basically we're solving for where y is equal to 0 because we're looking for the ground, which is considered at 0 feet above the ground. So that's it.